In this video, we will be looking at a problem of generating all possible permutations from the given array. Here is a sample input array and here are the sample output permutations of the given array. If you look closely, firstly, the first number is fixed, like we have fixed the number 3 and the remaining elements are swapped to generate the permutations. Then for these two permutations you can see that the number 2 is fixed and the rest are being permutated, and at the end the number 4 is fixed and the remaining are being permutated around. Now let's look at the pseudocode of generating all possible permutations before jumping into the actual code. We can take example of the same array. So our pseudocode will be like this. So first of all we will swap the first element, which is 3, with 3. We will swap 3 with 2, swap 3 with 4. So this will generate, because we are replacing 3 with 3, so the array will remain same. In this case it will become 2 3 4, and in this way it will become 4 2 and 3. Now the next we'll be doing is we'll be fixing the one element. If we fix 3 here, let's suppose the element 3 is fixed and we will be swapping the remaining elements. Now there are two elements which are remaining, so let's say we'll say swap 2 with 2 and it will generate 3 2 4, and then we need to swap 2 with 4 and it will become 3 4 2. So after this step you can see that we have generated the first two permutations, 3 2 4 and 3 4 2, which we are actually looking for. Now this pseudocode will actually is recursive, like there are only 3 elements. If there are more, like let's say if there are 4 elements into the array, then we will keep on uh, fixing the elements. Like firstly we have fixed 3, then we will fix 3 2 and swap the remaining elements, and so on and so forth. Similarly here, let's fix 2. So if this 2 element is fixed, now we will be swapping this remaining to 3 and 4. Now swap 3 with 3 and it will become 2 3 4, and then swap 3 with 4 and it will become 2 4 3. And our last element here is 4, so let's fix 4, swap 2 with 2, it will become 4 2 3, and at the end we will be swapping uh, 2 with 3 and it will become 4 3 and 2. So this way we have generated all the desired permutations here. These 6 permutations, 3 in this row and 3 in this last you can say column. Now let's look at the Java code of generating it. For the Java code I have already created the basic skeleton. Let's quickly go through it. And then there is a main method. It defines an array, calls get all permutation methods, and display all the returned permutations. That is another utility method, basically swaps elements of the array, which we will be using in our permutations method. Since the method we are going to implement here is recursive, so I've already created a recursive method. Here is the main method, get all permutations. I've created a permutations array and passed it to the get all permutations recurse, or short for recursive method. Here are zero permutations. This zero is the index, which means that till which index we have fixed the numbers. So at start we don't have any fixed number, then we will fix the first element, swap others, then we'll fix two elements and swap others, and similarly we will keep on going through this recursive call. Now let's look at this recursive method. To start off, let's iterate the array. We will start from the k and we'll loop through all the elements of the array. So here k is basically defining that how many elements are fixed, like we have seen in the pseudocode. So first of all we will swap the I and kth method, or sorry, I and kth index of the array, and then we will call this method again recursively, so that it keep on iterating by fixing the remaining elements. And after generating the permutations, we need to swap the elements back, so that for the next iteration we have the array in its original form. We have written the loop that basically iterates through all the elements of array, swaps them, and generate permutations. The remaining step is that when do we need to stop, or when we need to insert the array into these permutations. So when we have reached the last elements, that means k becomes equal to arr dot length minus 1. That means we have done all the swaps, and now is the time to store the array into the permutations. So since this is our array and the permutations array is an array list, so let's generate an array list of, let's call it permutation, and now we will simply loop through the elements of the current array and will insert it into this permutation. And after that we can add this permutation into our permutations array, which is basically storing all the generated permutations. So we have written the code for generating all possible permutations. Now let's test it. First of all, for testing I have simply specified the array we have seen in the pseudocode. Let's run this. You can see that it has generated all the desired permutations for us. For the testing purpose, let's try it on different arrays as well. If the array is 3 and 2, it will generate the two possible combinations, 3 2 and 2 3. And if the array consists of 4 elements, it will now generate the 16 possible, or sorry, 24 possible combinations which are listed here. So it's basically one of the basic formula is, if there are n numbers in the array, the generated permutations should be n factorial. So 4 means 4 factorial, 4 multiplied by 3 multiplied by 2, which is 24. So the output should contain the 24 elements which we have seen in our generated output as well. Uh, that's it for this video. I haven't added any null checks or you can say different sorts of boundary checks. You can always add them or can ask me in the comments of this video section. Thank you very much.